Hello, I'm Mark Nanaman, and this is my Sudoku app. I've been working on this in Power Apps for the last few months in my free time whenever I had a chance, and I've got it about where I want it to be. So I'm going to give you guys a tour of it, and I'm going to show you a little bit about how I use PowerFX expressions to generate unique and playable Sudoku grids. So let's just jump right in and take a look. Okay, so here I am on my Samsung tablet, and I'm going to go ahead and open up this app in the tablet. And the reason I'm doing this is because unfortunately on my laptop setup, when I run my screen recorder, it causes a significant lag on the app. I guess it eats up too much memory or something, and it won't generate the grid as quickly as it needs to. So here on the tablet, I can run the screen recorder that's built in on the tablet's OS, and it doesn't impact the generation time too badly. It looks like here we're taking about 11-12 seconds, and so it made the grid. Generally when I'm not recording, it'll take between 7 and 11 seconds, 7 and 12 seconds, somewhere in there. If it goes longer, it has a built-in timeout. It'll just reset and try again if it goes over 15 seconds. And occasionally the formula I came up with to generate the random Sudoku grids does occasionally hit an error, or it fails because it can't, due to how it placed the numbers in the set in the beginning. It'll sometimes get to a point towards the end where it can't complete it because of the constraints that are built into the Sudoku game, where you have to use 1 through 9 one time in each column, row, and grid. So here we've generated our Sudoku grid, and it's a collection of 81 items. Each item has an XYZ property, and that determines how it's placed here. And it's displayed in a nested gallery. So we've got this parent gallery, which just has a simple sequence of integers from 1 to 9. And those correspond to each 3x3 grid. And the child gallery, the nested gallery, filters our collection of Sudoku items, the 81 items. It filters them for a z value that matches the current integer. So here, this first box that's outlined in green is filtering for all of our Sudoku items where the z is equal to 1. The second one is filtering where z is equal to 2. And the third one, z is equal to 3. Additionally, the x and y properties determine where each item is placed in the subgrid. And then each item has a property that stores the number that we get to see. I call it the v property, v for value. And then it also has a property called is masked, and that determines whether or not we can see the number. And that's just chosen randomly based on our difficulty level. A certain percentage at random of these cells is chosen to have the is masked property set to true. And if it's true, it's hidden, and we just see this hashtag placeholder, and that means we have to guess the number. And I'll speak about a few other features. For instance, if you select a cell, like you select a visible cell, I select this one, it's going to highlight the column and the row, and it'll also highlight any other numbers of that value that are in the set visibly. So I can see where the other ones are placed, and I can kind of use that to help me deduce any cells that might be another 1. So looking at this, I can tell basically I know anything that's in the highlighted row and column cannot be a 1. And let's see if we've got enough info here to make any decisions. Well, we can see here that basically either this cell or this cell is going to be a 1. So let's take a guess. I'll just hit 1. We guess correctly. If you guess incorrectly, it'll pop up and say incorrect, and you'll get a strike against you. So let's do another one, see if we can get an incorrect. So over here, I know that one of these two needs to be a 1. So let's guess this one. Incorrect. And now over here in my left panel, I've got a 1 of 5 errors. I've got a little progress bar there. So if I hit 5 errors, I strike out and I lose the round. So since that one wasn't a 1, I know this one should be a 1. Now I can tell that this one right here needs to be a 1. And let's see, so one of these guys is a 1, or two of them are going to be a 1. Try that one. I got it correct. So now I know this one needs to be a 1. Now I've got my 1s completed. So I'll just play this through and time speed it up. All right, looks like we completed it. And now I get this little animation when it's completed. And after it completes the animation, we jump right into regenerating a new grid to play another game. All right, let's take a peek under the hood to see how this all works. So first I'll just talk briefly about how I display the Sudoku grid. There's a parent gallery, and then there's a nested gallery. The items in the parent gallery is just this simple array, this sequence. It's a 9-item sequence starting with 1. So it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a wrap count here of 3. And so that wrap count makes sure that we only go over 3, and then we go down and go to 6, and then we go from 7 to 9 at the bottom. The nested child gallery gets its items by filtering our collection of Sudoku grid items, which contains 81. So there's one item for each of the cells here. But we filter for the cells that have a Z value that matches the current number for the parent gallery. So this first nested gallery is looking for Sudoku grid cells where the Z is equal to the parent value, this item dot value. So in the first cell, that's going to be a number 1. So we're filtering on Z equals number 1. The next one is going to be Z equals 2, Z equals 3, 4, 5, 6, and so on. And we're ordering it first by our X values and then by our Y values. And to help visualize the Sudoku grid collection's coordinates and how they're displayed in the nested galleries, I do have this label text control that is normally hidden, but I have it there for debugging purposes when I was building this out. And I'll just turn it on to visible now and expand this. We'll be able to see a little bit better. And so we can see each item's coordinates, and the first number here is the Z. So if you notice in this first square here, all of the numbers start with a 1, and then parentheses we have the X and Y coordinates. So the first cell is 1, 1. The next one down on the X-axis is going to be 1, 2. So instead of like a normal Cartesian plane, the number increases the further down it goes. So we're starting in the top left, and we increase as we go down, and we increase as we go to the right. So here we've got X of 2 and Y of 1, X of 3 and Y of 1, etc. And then in this next square, this next 3x3 grid, all the numbers start with a 2. The Z coordinate value is a 2. Over here, the Z is a 3, 4, 5, 6, and so on. One goal I had when building this app is I wanted to generate the basic Sudoku grid, the 81 cell items. I wanted to generate them almost instantaneously using PowerFX code. I didn't want to have to type out a whole array in JSON or anything that had everything I needed. So to experiment and help come up with the formulas I would need to do that in PowerFX, I just played around here in Excel, and I'll show you how I did it. So here in Excel, I've got this table, and I've got this column called ID. And then I've got a column called X and a column called Y. And basically my idea was, okay, I have 81 cells in my collection, 81 records. And when you think about it, the X and Y coordinates are in a way encoded in the numbers 1 through 81. You just have to tease them out. And here's how I did that. So for my X, I basically saw that if I if I divide the ID by 9 and round it up to the nearest integer, and then multiply it by 9, and then add 1, and then subtract the ID again, I'll get an X coordinate. And for the y, it's a little simpler. If I take the ID and divide by 9 and then round that up to the nearest integer, I get a good y coordinate, and it'll plot out nicely. So what I can do is here in Excel, I can just drag these down until I get to 81. And now it has automatically created the XY coordinates I need. If I look here under my X's, I've only got 1 through 9, and I could just select any one of them at random, and I should get 9 of them. So it should have 1 through 9, and each one should be in there 9 times. And here I've got them selected, and I see I've got 9 for my X's. And the same is true of the Y's. I can also double check that the coordinates are proper, and they'll plot a proper grid by throwing in this little scatter chart. Let me just select my data again. Okay, so here is the expression in my Power App. I've got this on the onSelect property of a hidden button, and then there are other buttons in a couple other places that the user can click, and it will select this hidden button to run the code. That's a way I can have the function be reusable. It can also be selected by timers in a few places. So for instance, when the user completes a game, there's a little congratulations animation sequence, and when the timer for that runs out, it will just auto select this to start the process over again and make a new grid. And this part runs basically instantaneously. So we collect a collection called Sudoku, excuse me. And I'll start from the inside and work my way out. We start with the base of this is a sequence for 81. For some reason here I did 9 times 9. I didn't type in 81. I typed in 9 times 9. And that's how many items are going to be in the sequence. And then we're going to start with 1. And then the next thing I do is I rename, because when you do the sequence, you get a simple array. And the simple array is going to have, it's actually items, and it's got a value name. The column name is value. The property name is called value. And just to avoid confusion later on, because at one point I wanted to call the number that was visible value, I renamed it to ID, because that's how each of the numbers is unique for each cell in the collection. And so that's basically the same thing as an ID. That's kind of like your IDs in SharePoint. So I rename the default value column to ID. And then I do an add columns. And here's where I do my X and Y like we did in Excel. So here for Y, I do a round up on the ID divided by 9, and we round up to 0 decimal points, so the next integer. And that's all I do for my Ys. For my X's, I do I take the ID divided by 9 and round that up to the nearest integer, and then I multiply that by 9, and then I add 1, and then I subtract the ID again. And I have to admit, it doesn't make sense looking at it right now, but it works, and I figured it out in Excel, so I know it works, and so I just keep it like that. Maybe there's a better way to do it. There's probably better ways to do everything. After this, I add a column called V, and V is what I ended up using to display my number. So the random numbers you see in each new Sudoku grid that show up, those are in a property called V. But since right here at the beginning, I just make each one 0. So we're just creating the basic mother collection, and then later we'll shuffle it and we'll add unique numbers here between 1 and 9 for the V property that match the constraints of Sudoku. Next, I add this isMasked property, and it'll be false by default, but that is going to drive whether or not we can see the number or we have to guess the number. After that, I add this property called vals, and it's a table of a sequence of from 1 to 9. So we do a 9-item sequence starting with 1. And basically that's going to be used later on to help randomly pick a number for the V property. And anytime we'll redo this val, we'll use the vals to see what's available to choose from. And when a number becomes not available, it won't be in the vals anymore. So it can't be chosen for each cell. And then next I've got this used property, which is basically the same thing as the values property, but in reverse. It's going to show all the numbers that were used as we process and shuffle the Sudoku grid. Anytime a number gets chosen for something in the X, Y, or Z that pertains to the cell, we'll update the used here so we know that those numbers can't be used. And I mainly did that for debugging purposes. After that, this is an important part. I calculate the X and Y coordinates of the top corner of each grid. And this is based off of the X and Y's that we came up with earlier. So for the grid X property, I take the X and divide by 3 and round it up to the nearest integer. And for the Y property of the grid, I do the same thing, divide Y by 3 and round up to the nearest integer. After that, we do another add column where we actually calculate the Z value. And so Z is going to be, again, from 1 to 9. And we do that by taking the ZY, subtracting 1, and putting that in parentheses, multiplying it by 3, and then adding the ZX. And again, that's something I tested out in Excel, and it works. It gives us our 1 through 9, 3 by 3 grid numbers. And then I sort it by Y and then sort it by X. All right, now that we've seen how we generate the basic collection for our Sudoku grid items, I'll talk as briefly as I can about how I shuffle them or populate them with randomized numbers. So I've got this button here called New Grid that the user can click at any time to start generating a new grid. So we'll just go ahead and click that. Clicking that button gives the user this pop-up where they get to confirm that they want to create a new grid. They can click confirm there. They've also got this slider where you can set the difficulty, and that's basically the percentage of cells that will get randomly masked. Now, when the user clicks confirm, that selects the hidden button we looked at before that resets the Sudoku collection that we call Col Sudoku. It resets that, and then it also starts this hidden timer I've got here. And the duration on the hidden timer is half a second, 500 milliseconds, and it will repeat until the grid has been successfully populated. So it just every half second it runs again, and the code for shuffling the numbers, for placing our numbers in the grid, is on the onStart property, on timer start, right here. So every half second it tries to run this code, and the code is going to check to see if each time it starts running, it'll update a local variable, a local Boolean. And so the code will just check if that local Boolean is true or false before it does anything. So if it's still running, it won't do anything. It'll also check to see if the whole collection, the whole set has been populated with random numbers. If it has, then it'll complete and it'll update a local variable to turn the timer off. So the timer no longer repeats, the code no longer runs. It'll also update a variable to hide the pop-up. So the pop-up goes away and it's time for us to start playing the game. So that's kind of what's going on up here at the top. We've got this if that starts, and then we do an update context to update a lot of variables, a lot of local variables that drive this thing. And I'm gonna try not to get into the weeds too much on this because it is a lot. I do have the entire code pasted in my articles that you can check out below. So if you want to copy paste that code, you can do it there. I'm also going to try and include a link to where you can download this app. And so it might not be there immediately after the video is posted, but you can check back, and there should be a link in the description, and there should also be a link in the article where you can download this from GitHub or something. I haven't figured out exactly how I'm going to host the app yet, but I'll make it available for download and suggested donation of 99 cents or something. So after the conditions run, if it decides that, okay, we're not currently running this code and it's not complete yet, it's also going to check to see if the last column we processed, if there are any blanks in it. If there are any blanks, it's going to reset that column. All the V's are going to be reset to 0. It'll also reset every cell in the 3x3 grids in that column to 0. The reason for that is I never came up with an expression code that could basically see into the future and know that if we place these random numbers in this random order, we can complete the whole grid. There might maybe if you're a super genius math whiz, you could help me out here and figure out a formula that would that would eliminate certain arrangements that are impossible to complete for a Sudoku, but I couldn't figure one out. So what happens is occasionally, not too often, but occasionally it's going through a row and it can place like 7 or 8 of the numbers, but it can't place them all because the number it's left with has already been used in the remaining cells, row or 3x3 grid. And so it fails basically. So the way I solve for that is if it fails, we reset the column, we reset all the grids that that column was in, all the Z's, all the cells with the same Z, and basically take a couple steps back and start over. And hopefully the random process will place the numbers differently in a way that can be completed. And for the most part, it almost always completes eventually. And I do also have another failsafe here where if the process takes longer than 15 seconds in total, we just wipe the slate and start over again. And I've never seen that go longer than 2 attempts. Like sometimes it'll time out on the first one and then it'll reset, but I've never seen it go longer than 30 seconds. And when I'm running the app with nothing else, no screen recorder on my system, it generates a grid between 7 and 11 seconds, 7 and 12 seconds every time. So what happens here when it goes through the if statements and it decides, okay, the last column was done correctly, we're not completed, we need to move to the next column. It'll find it'll find a cell, it'll find the next column that's empty, and we'll go through that, and it's going to basically calculate what numbers are available for each cell in that column. And it'll do that by doing some filtering and show columns. So it'll filter on all the cells in that row, in each row in that column, and each Z grid in that column that have numbers. And so that way it can determine which numbers are available for those cells. And then we can go through and randomly pick those. That's a 10,000 foot view of what's happening here. And it was just a lot of trial and error to write the code here in a way that worked as quickly as I wanted it to. I wanted to get it as close to instantaneous as possible, but it looked like 7-8 seconds is about as quick as I could get it to run. The options for making this run faster, I did come up with one option to make this instant, but that involved generating the Sudoku grids beforehand. So I came up with a Power Automate flow that could run on a schedule and just batch create Sudoku grids and store them in SharePoint or Dataverse. And so I could just have a whole bunch of them that are generated in the background, and then the app would just pick one that hadn't been played yet at random to import each time the user wanted to play a new game. So that would make it instantaneous for the user. However, I wanted this app to run without any external data sources. I didn't want to have it connected to SharePoint or Dataverse or SQL Server. So that's why I settled on this method here. And I figured the the 8 seconds to generate a new grid wasn't too bad. After it's calculated which numbers are available for each cell, it's going to loop through all the numbers it needs to place in that column. So each column needs to have 1 through 9 placed in there somewhere, one time each. And so that's what it does here. It loops through each integer, the 1 through 9, and then it's going to basically, it's going to look for the cells that have that integer in the list of available, and it's going to sort them accordingly. So it's going to kind of look for, it's going to look for the ones that have the least number of integers available for that cell and try and do those first, and certain methods like that that reduce the amount of fails that you get. Like I said, it's a little too much to get into in the video. It's even a little too much to get into in the article I posted, but I do have the entire expression pasted into that article. So if you really want to figure out how it works, you can go through the code in the article or download the app and open it up yourself and look at it and get a feel for how it works and improve it if you like. And if you do improve it, let me know how you improved it. I would love to be able to get this to generate in like a second. There are a few other features of this app I will show off real quickly. So here we've got the generic Sudoku game where it's just numbers, but I thought, well, why not switch it up? So I put some options down here below to change it. So we can do the standard number version, or I can click ABC, and now each number will be replaced with a letter, A through I. And so we can play it this way. I also have a colors version. So here's our colors mod. So we can play by colors. Also have a wingdings version. So we get wingdings symbols. There's an icons mod. And these icons are also kind of randomized. Like I've got a big set of icons and it'll randomly pick 9 of them to use. We can also do Roman numerals. They are a little too small right now, so I need to make them bigger. I can also do languages. I also was a little bored one day and I just used ChatGPT to give me basically make a JSON array showing all like 1 through 9 in a bunch of different languages, and then put them in here as an app formula, and we can convert our numbers into different languages. And so we can play by different languages if we want, like Japanese, for instance. There's also a timer clock over here that'll start running when you start playing the game. This, I've done another video on how I built this SVG timer clock. We do also do some statistical tracking for wins and fails, and your best time for the game and your last time on the game. That does violate one of my rules about not having any external file sources. The way I do that, there's a simple Power Automate flow attached to the app that will save a text document basically in your OneDrive. So it makes a folder for the Sudoku app and it saves a text file there. And the text file has a fairly simple JSON array, and it just logs each game you play, whether you lost or won and what your time was for it. All right, well, there's a tour of my Sudoku app game that I built in Power Apps. I hope you enjoyed watching the video. Hope you got some ideas. Maybe you've got some ideas on how I could improve this and get it to generate the new grids quicker. If you do figure any improvements out, please let me know in the comments below. Check out the blog posts in the comments below to get some of the expressions and code I use to do this. And also look for a link to download the app and play it for yourself. I'll try and put a link in there at some point, maybe not right away, but some point soon. I'll try and have a link in the description and in the article linked about how to download the app. I'll try and put it on GitHub or something, and you can download it. Anyway, thanks so much for watching and have a great day.